So here we have a simple but interesting question. We have to compare the first and second ionization potential of copper and zinc. So whenever you need to compare the ionization potential, write down the electronic configuration of both the elements. So we know that the atomic number of copper is 29 and that of zinc is 30. You must remember the atomic numbers of elements at least up to 30. So for copper, let us first write the electronic configuration. This becomes equal to 1s2, 2s2, 2p6, 3s2, 3p6. Now before the 3d orbitals are filled, we fill up the 4s orbitals. How many we already filled? 2, 4, 10, 12 and 18. We need to put in 11 more. Now after the 3p are filled, we start filling the 4s orbitals. So this becomes 4s2. This is because of the n plus L rule. The n plus L for a 4s orbital is n is 4, L is equal to 0. Therefore this becomes equal to 4 plus 0 is equal to 0. We did not fill the 3d orbital because for a 3d orbital n was equal to 3 and L was equal to 2. Therefore n plus L became equal to 5. So before filling the 3d orbital, we fill up the 4s orbital. Therefore this becomes 4s2 into 3d 9. Now actually what happens is that the electronic configuration of copper is not this, because let us check out. Let us draw this. We have filled in the 3p orbitals. After filling the 3p orbitals, we have the 3d orbitals like this and the 4s orbitals like this. Now instead of this, if we did it like this, that the 3p orbitals are fully filled and we fill up the 3d orbitals and this 4s has only one electron. Now this is a special case of copper. It happens only like this only in copper. So remember this special case. This also occurs in case of chromium. The important thing to realize is that why is this configuration true? This is because a fully filled orbital and a half filled orbital is always better than only one fully filled orbital. In this case, this is arbitrarily filled, whereas in this case we have one fully filled d orbital and one half filled s orbital. Over here we have one fully filled s orbital and one arbitrarily filled d orbital. Therefore always remember that one fully filled and one half filled is always better than this case. Therefore we write the electronic configuration of copper as 3d10 4s1. So always remember this change happens in the case of copper and chromium. So we know the electronic configuration of copper now, and we have to use this configuration for all questions in the future. Let us write down the electronic configuration for zinc. This will be equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s2, because we have one electron extra than that in copper. So let us first compare the first ionization potential. Now for comparing the first ionization potential, we see that the electron, always remember that the electron is always taken out from the outermost shell, that is 4. You may be filling the d orbitals, that is 3d5, 3d6. You may have this sort of configuration 3d5, 4s2. You keep, when the electrons keep on coming, you keep filling in this, but always remember when you're taking out the electrons, they always are lost from the outermost shell. Therefore for comparing the first ionization potential, we find here that the outermost shell of zinc is like this, that is 4s, and for copper it is like this. Now since this is fully filled and paired, therefore it is more difficult to take out the electron from here than here. Therefore the ionization potential of zinc will be greater than that of copper, that is first ionization potential. Therefore first ionization potential of zinc is greater than first ionization potential of copper. So we get the answer for our first ionization potential, because it is tougher to remove an electron from a fully filled 4s orbital than from a half filled s orbital. Now for comparing the second ionization potential means that they already exist in the form of Cu plus and Zn plus, and we need to remove one more electron. Now always remember that one electron, when it is removed, it is always removed from the outermost shell. Therefore the configuration of copper plus becomes equal to 3d10, and of zinc becomes equal to 4s1. Now when we remove, for second ionization potential, we have to remove one more electron. So when one more electron is removed, it has to remove from the d orbital of copper, whereas it has to be removed from the s orbital of zinc. Now this is singly filled, this d orbital is fully filled. Therefore it is easier to remove the electron from here. Therefore the second ionization potential of copper will be greater than equal to the second ionization potential of zinc. So our answer comes out to be the first ionization potential of zinc is greater than first ionization potential of copper, and the second ionization potential of copper is greater than the second ionization potential of zinc.